Hello and welcome to a new section of the course. In this section we will talk about testing and how you can test your applications in Compose. So what we need to know first is that Compose uses a concept called semantics for testing, in which a semantics tree is created for your Compose UI components. So let's create a project and we will discuss along the way how it works. I create an empty Compose activity. I name it my Compose test and I create it in an appropriate directory. A minimum SDK of 24 is selected. I leave it to default and press finish. We wait for the project to be created. Okay, our project has been created, and now the first thing we need to know and we need to make sure of is the dependencies for test has been added to our project. So we go to the build.gradle script file in the app module and we check for these dependencies: UI test JUnit 4 and UI test manifest. And the first one is prefixed with Android test implementation and the other debug implementation. Also, you can see that we have Android test implementation for the Espresso Core artifact. This is important because in case you want to interact with Android views and you have a hybrid application that uses both Android views and Compose UI, then you will need to use Espresso for testing Android views and Compose test for testing Compose components. Therefore, that's why we have added Espresso Core as well. And this is added by default by Android Studio, so we don't need to do anything on our part for the projects that we create in Android Studio. So first I'm gonna remove these composables and I'm gonna create a new composable. I'm gonna name it my box and I'm gonna create a variable called greet by, remember, mutable state of false. First it's gonna be false. Let's import mutable state of and remember, as well as get value and set value, because this is a delegate. And then I'm gonna make it I'm gonna create a box for a greeting. I'm gonna put a text inside it, welcome, and with a font size of 50 SP. And this I'm not going to show this all the time. I'm gonna show it only when the greet is true. Therefore, I'm gonna put it inside an animated visibility. Animated visibility with this. So I cut the text and put it inside animated visibility, and I'm gonna pass a value to control animated visibility content. So I pass greet to it. Just as simple as that. And for the box, I'm gonna allocate all available space, fill max size, and then I put a button inside it to control the greet value. So greet, so I add a button here with the text of greet me. And for the onClick property of button, let's import button first. For the onClick property, which is the first parameter, I'm gonna enable greet, switch it to true. Just as simple as this. And we can also enable preview. Okay, I'm gonna call it inside surface. Let's see the preview with build and refresh. And while it's being built and refreshed, let's check out our test and where we need to add the test. Note that you need to make your compose test inside the Android test package. And why we created under this package, it's important because Android compose tests are instrumented tests, which means they are supposed to run on an Android device or on an emulator. So we write them under Android test. So we go to this package. You can check out the template example that has been created by Android Studio. I'm going to skip that and create a new file, Kotlin class. I'm going to name it my awesome test. And I'm going to create, the first thing I do is create a rule. And this is a compose rule. It's very important. The way we create it is like this. Val rule or compose rule, create compose rule. But you need to annotate it with get rule. So make sure you do that. Also, if you need to have access to a certain activity, you can create this compose rule using create Android compose rule with this. So I'm gonna skip that and just use create compose rule to make things simple. And once I have the rule, I can test different scenarios. The first thing I'm gonna show you is showing you the semantics tree that I talked about. So I create a simple test to show that. So I add an annotation for test. I import it from org.junit_test, and then I name my test with this print semantics tree. As I said, we have a semantics tree created for our compose UI tree. So we print it here with compose rule. First, you need to set content, because compose rule doesn't assume any content by default. You need to specify the content that you need to have for your rule, and then you can test different scenarios inside it. So first, I set the content, my box, I specify my box inside it, and then I simply print that tree that is available in my box. So compose rule on root, and then we have an important property here called use unmerged tree. If you use unmerged tree, the default value, which is false, then an unmerged tree will be used, which means that some of the available nodes in this tree will be merged to each other. For example, if you look at button that we have in our box, button has two components, one button and one text. So if you use the unmerged version, both the button and the text will be mentioned in your compose semantics tree. But if you use the unmerged tree of true, if you use the unmerged if you use the merged tree, which means you use unmerged, you set the flag for use unmerged tree to false, then both these components will be merged to each other. Therefore, we set this value use unmerged tree to true. We don't want it to be merged, so we use the unmerged tree. And once we are on the root, then we can print to log with my test log, my test tag. We specify a tag for our log with this. Okay, now let's run our test and print our semantics tree. I select this button and run my awesome test. Okay, you can see that our test was launched and the functions inside our test class were successfully run. You can now check the output log for the tests, and we are looking for the semantics tree that was run here and was printed here inside the logs. So let's look for that. Yes, that's here. You can see that the tag is here, my test tag, and here's this tree that has been printed, node number 1 at these coordinates, left 0 0, top 36 0, and right 480, and bottom 800 pixels. And again for node number 2, which is our button, we have left 0, top 45, right 148, and bottom 99 pixels. So we have 4 nodes in our tree. Each of them have their roles, you can see, with their actions and some other properties that are specific to the semantics tree. So this was for semantics tree and how you can access it and how you can log it for your tests. In the next video, we will talk about how you can access different components, how you can find different components, you can perform actions on them, and you can test their behavior. So stay tuned.